Thank you for coming today. We've got Chris Lucian with us, and he's the director of software development at Hunter Industries, which I've actually met a few people from there here recently. So it's been fun learning about what they do. He does mob programming and is co-host of the Mob Mentality Show. They had me on here a while back, which is where I met Chris. Um, he's going to be talking to us today about causal loop diagramming, and so Chris, I'll turn it over to you and have at it. Looking forward to this.
Awesome. Thank you so much. Yeah, so this is a kind of an interesting tool that I had been using, and it really came in handy during a particular event. But kind of backing up a little bit, um, in in the book, The Fifth Discipline, there it talks a lot about cause and effect and second order effects and things along those lines. And so when reading that, there's a very short excerpt that talks about causal loop diagramming. So that's a lot of where this came from. And the reason that this title is around the causal loop diagramming for cross-disciplinary insight is that I kind of used it a collaboration tool. So um, I am on a team that is composed of software development, salespeople, marketing people, uh, um, other aspects of engineering, and so on and so forth. And so on that team, after we'd read that book, it really resonated with us, especially since we were seeing a lot of side effects from all of the impacts to manufacturing companies during COVID. And so that was a really good book to read during that time. And so I said, hey, why don't we do causal loop diagrams? So I did this exercise with each person individually. It took about 2 hours with each person pairing. I got really good at the drawing tool to do the diagramming, and then it went from person to person. And what we found is that, and then we got together and shared, right? And so when we shared the diagrams, we were able to connect them to each other. And so we could see an investment in one department could affect the metrics of another department. And this became a really big insight for us. It changed the way that we decided to do investment at the company at the time. And so it was a really cool thing. So I'll jump into this a little bit, and then if we can get into it, we can do some either collaborative drawing or something along those lines, if we get to that point and have time. So we can jump into it. This might be an example causal loop diagram. And you can kind of see, developer skills, dealing with good code or bad code, whether or not you have process issues, adding Kanban and training and Agile XP. And so that's kind of an example of like a single one. So we want to talk a little bit about, drawing these diagrams. So that tool that you saw there was at the ncase.me, and I'll put a link in the chat, and it'll be on the screen a number of times. And so I kind of have an example here. This example is the kind of based off of the video that Yellowstone put out for kind of the before and after. So the bottom screen is before they made these changes based on the systematic impacts, and after. And with a key area of concern, which is like healthy foliage on the park. And so when you look at, what's the most important quantity to you right now, that's a good place to start for these diagrams, because the bubbles on the diagram are those. So there's the URL down below if you kind of want to follow along or play with it. So if you're saying, healthy foliage is a key metric that you want to track, then you can kind of see the cause and effects, and this might be, software produced without bugs or something along those lines. And so then you kind of ask the question, how does that quantity affect the others? So does the healthy foliage increase the number of grazing animals? Does it impact the ecosystem in a certain way? So You might start here, right? Healthy foliage increases the stable ecosystem, and it increases the number of rabbits I used in this example. In the Yellowstone video, it's deer, but it's kind of a similar idea. So this idea where that if this quantity increases, then other quantities increase as well. So then you look at this and you say, how is that quantity affected by other quantities, right? And so we know that the rabbits increase if you have increased amount of healthy foliage, and the number of rabbits increasing then decreases the number of healthy foliage. And so you can kind of see almost like a breathing motion here. So the foliage is growing at a certain rate, and then the number of rabbits are decreasing the amount of foliage, right? And so the ecosystem kind of breathes, so to speak. So then you kind of ask yourself, do you see a balancing loop, any number of loops with an odd number of minus flows? So, each flow can have an increase causes an increase, or an increase causes a decrease. And so the balancing loop can be identified here because the amount of rabbits balances across that. In here, the healthy foliage is growing at a certain rate, and it doesn't grow uncontrollably, right? Because the rabbits are grazing. So then, do you see a reinforcing loop anywhere? Any number of loops with an even number of minus flows. So, if you decrease something and then decrease again, it actually inverts the sign and causes an end increase. And so in here, I see a reinforcing loop as well. And that's because the number of rabbits gradually increases. And you can see that everything is a lot less stable here, right? Because the number of rabbits increasing also causes additional decreases. Then you kind of ask the question, are there delays, and how strong is the loop? And what you'll find is that well, in that tool that I showed, it's you drag out the arrow to make it longer, and so you can kind of see here the healthy foliage growth, rabbits reproducing uncontrollably, and so yeah, you kind of see these effects where this balancing loop gets uncontrollable, right? And that's where you get all the brown landscape, essentially, is that the cause and effect. So in here, you can say like, okay, well, we have this kind of exponential reduction uh, in healthy foliage because our grazing animals are completely out of control. And so when you uh, you then can look for ways to introduce other effects to strengthen or weaken certain things, or cause another exponential impact on the system. And so that's where you identify those balancing loops. And then when you connect different diagrams, you can kind of create a whole ecosystem. So in our example here, adding carnivores can stabilize the ecosystem because they will hunt the rabbits. That'll increase the number of carnivores. But as the number of rabbits decrease, then that'll decrease the number of wolves. And so you kind of, again, reintroduce a ecosystem. So, there's the book, The Fifth Discipline, and the wolves, how they change rivers. So I have that, like, this very short version of the presentation because I kind of wanted to talk more and do some drawing, on that website. But yeah, I saw a lot of questions in the chat, so maybe we can go through some of those, or if anybody has any questions while I get set up to do this thing here.
I'm not sure if we had any specific questions. One person was saying they were seeing a security error when going to that site, but it seemed to work for everyone else. I'm not sure if that's something you've seen.
Right, yeah, I don't think it's HTTPS probably, and so that might be restricted on some people's systems. Let me share my screen again. Share. Okay, so you can always use like draw.io as well. So let me pull up or Visio or any sort of diagramming tool. So gonna create a new blank diagram, um, and we'll go from there. So this is an example of um, so on the right is draw.io, and on the left is like loopy, or draw.io functions very similar. Like you're not going to get the animations, but you can still, when I did this exercise with our teams here, we did it in draw.io. And so you can kind of say, you can create these sorts of connections really like that. And you can say, label these however you want. So that's just one way of doing that. The simulation kind of looks interesting to people when doing that, and so that's kind of how we do that. But for example, if we want to say, something like quality code, right, is being produced, right? So then we can kind of talk a little bit about where are the side effects, um, and yeah, and so and I see in the chat somebody posted the how wolves change rivers. So I just like that example because it's a complex adaptive system, and then there's like an analysis that goes in to it. So quality code can or even satisfied customers or something along those lines would be better, right? So software user, um, and right, satisfied, right? So what affects this quantity? And so you can say something like uh, a working feature, right? And you can draw a line to it. So working features increase the satisfied user, and but there's no loop here, right? Um, but then you can kind of say, for example, um, you know, uh, developers write code, and you can say, oh, okay, so if you assume, and again, like no model is complete, and if you assume that creating a working feature produces a satisfied customer, um, then you know that sort of thing can continue forward. But we know that our system is more complex than that. So what other things kind of happen, right? There's like introduction of bugs. There's also this kind of thing where we say, the um, money paid for the software, right? So if you have money paid for the software, then that increases, by the user. So the satisfied user, they might pay for money, they might upgrade, whatever, and then that might lead to additional developers, right? So now we have kind of a reinforcing loop. And so if I speed this up, you can kind of see it just travels around and around and around, right? Um, so so similarly in our system, we can say like, oh, bugs discovered, right? And you can then say, okay, well, the bugs discovered will then lead to other things. Like, one thing is that we're going to have less ability to do development because of working features. And actually, instead of that, I'll do this. So we have fewer working features because uh, we're going to cause that. So then again, we can kind of say developers write some code, and then you get this, really erratic behavior kind of in the simulation. And again, the simulation is not something to really pay attention to, except it gives you kind of a good idea as you're adding nodes, um, you know, if your spacing is correct and things like that. And so, yeah, because everything's bouncing around a lot like this, you can see that it causes some like chaotic stuff. Um, and then that reduction in satisfied users then can lead into that. So a lot of this can justify, or help with understanding, in the agile world or extreme programming world, like, hey, we want to, reduce this balancing loop's effectiveness. Well, how do we do that? You can say code coverage, right? Or yeah, code coverage, unit tests, right? Unit tests or zombies cases, right? And so adding unit tests will, you know, uh, will then um, reduce the number of bugs discovered and depending on, I can leave that arrow out, but depending on how you look at it, if you really believe in like TDD, then you can kind of say uh, additional working features. So again, we kind of go through here and you get that sort of thing. And so at some point, then you can talk about code coverage and other things along those lines, right? Now, another piece, one thing that was a really interesting discovery along all of this was the effect on other teams. So, say you have tech support calls, right? And uh, that those people in tech support um, will sometimes they'll just be called by the user, right? And sometimes they'll be um, interact. So maybe like tech support calls handled, um, and versus tech support not handled. And so a satisfied customer might go to the tech support and it gets handled, but maybe a bug discovered causes it to get not handled, right? If it's not handled, then they might bother the developers. So you're back along here, and you reduce the amount of development capacity because that person has to answer that call. So you can kind of see that there's a large delay here because they talk to the tech support person and then it uh, operates that way. So now you can say like, oh well, if we invested in people that can handle calls or invested in reducing the bugs, then you can actually see that the staff for the tech support team and the staff for the development team are directly related to each other. And investment in unit testing can reduce the need for tech support staff. But if you want to really eliminate that reinforcing loop, or increase tech support staff can reduce the amount of calls going to the developers. But if you really want to eliminate this reinforcing or this reinforcing loop, because there's an equal number of minus signs here, if you wanted to get rid of this reinforcing loop or reduce its effects, then reducing the bugs ahead of time is actually more important. And so adding unit tests can actually cause like staffing considerations downstream of that to widely differ. So I don't know if everybody is doing well and yeah, if you need satisfied users, add more wolves. Um, right. So, any questions so far along the lines of all of this? Just want to open it up in case there are more.
So I had a question. I noticed on the when you're doing the rabbits to show a stronger effect, you just show more like just put more loops in. Is that how you make the effect stronger or less?
Right. Yeah. So there's certainly the scenario where yeah. So for example, you can add a second arrow here or a third one, right? And so if you're adding more unit tests, then you can say, and that's just again in this tool, right? So in the other tools, and you can see actually adding a lot more unit tests actually greatly reduces the bugs discovered, and that's why it's not colored in anymore. And that then reduces the number of tech support calls, which then reduces the amount of times that we uh, negatively impact the software team. And so if the software team invests in unit tests, they actually get capacity back, right? Um, and while the team up here continues to hold on to those things. So yeah, and then delays, right? So in this tool, a delay is represented by widening. So like if features take longer to build, then this is what it looks like, right? Um, and or iteration. So you get these bursts of bugs and the bursts of tech support calls. And so um, uh, generally speaking, you might see if you build longer features and they take longer to do, rather than continuously iterating, then you can actually see that the tech support team will be affected in bursts as well, right? And so you might have a more even capacity need for tech support teams if you reduce your cycle time, right? And release more features more smaller features more frequently than what kind of the effect of that, right? So those are the ways that you do that. Traditionally, in something like draw.io, or hand drawn even, two vertical lines represent a delay. So if you do, oops, you do something like this, then the two vertical lines like that represent a delay. And then you can do like wider arrows for increased strength and things like that for those impacts. But yeah, again, um, and basically it's really about identifying those reinforcing loops and those balancing loops. And a lot of these effects create systematic impacts that are really interesting in that regard.
Did anyone else have any other questions while we kind of got a pause here? Feel free to just come off mute and speak up or throw it in the chat if there's something, a question you've got about it. Good.
I mean, I've got a question.
Yeah, go ahead.
Can you incorporate things like inventory?
Yeah, absolutely. And in fact, inventory is inventory is a quantity, right? And so, um, you know, are you speaking in the sense of software inventory, or just like manufactured product inventory, or how are you looking at it?
Well, I'm thinking about business processes. Like, you got a stack of invoices you got to deal with. That's inventory.
Right. Yeah, exactly.
That kind of stuff. Which
So
slows
that
things
is a
down.
quantity, right? And so you might say, so like you have committed code not released to production. So like, um, uh, if you have committed code not released to production, that can be a quantity before it can, become a working feature here, right? That would, in the software sense, results in inventory. But, if we started a new diagram here and, really took a look at all of these things. So let's delete these nodes. We can just say, a widget of some kind. So like say you're like a battery manufacturer or processing invoices, like you just said, right? So, how do invoices come in, right? So you might have like a uh, customer, creates order, then that leads to an increase in invoices. The increase in invoices then leads to some other part of the process, right? really it's not, yeah, sorry, these should be nouns. So like orders, right? Orders lead to invoices, right? Um, and so invoices then lead to, some other quantity. And so then you can talk about your capacity for processing those invoices or something, right? So, invoice processors might be processing those invoices. And so then they would reduce that. Um, and, every time there is an invoice, then it can lead to some other side effect. So if you wanted to flesh out that concept, we could do that right here. So it's like, what are quantities that are affected by the invoices? Would you be interested in doing that?
Uh,
If not, it's all good.
No, I mean, let's see any example that demonstrates the
Yeah,
the
I like the
concept.
idea.
Yeah. So, yeah. Well, yeah. In general, so you have like the thermostat example. So like a very traditional example of this is, the current temperature. And then, you have a heating and cooling system, right? So the heater running, right? So the number of minutes running, right? And so that will increase the temperature, right? And so then you also have the AC minutes running, AC minutes running, and that will end up reducing the temperature, right? Um, and so these are all, disconnected items. So we run the heater, it does the temperature. And then, so a thermostat, right, will then say if it's lower, run the AC, if it's higher, run, so the minutes will increase depending on um, the reduction, right? And so if the temperature is lowered, it will increase the number of running. If the heat is increased, it will lower the amount running, right? So, then the system can operate that way. So let me see, like thermostat. Get an example of this. And so there's a balancing loop in this system. Um, and or the other one that is very popular to be used is the population with deaths and births, right? So you have a population. As you increase the population, you have an increased number of deaths, right? And there's a long period of time for that to happen. So the population, there's a delay, and that increases the number of deaths. The number of deaths decreases the population, right? And so if you just leave that in an endless loop, then it just kind of goes back and forth in this sort of diagram. Then you add births, right? And there's a delay in the population. As you increase the population, you increase the number of births, and then you increase the number of the population. And so this is a classic example of where you would add a reinforcing loop, reinforcing loop, and a balancing loop, right? And so then the population kind of grows and decreases. And so, yeah, and then if you drag these out. So these are kind of like more concrete examples of how causal loop diagrams can model a system. But you have to get sufficiently complex to make new discoveries. And so, yeah, product quality is often a really good one to look at. I think I saw a chat come in. Yeah, so the typical use, so the question is, what is the typical use case for this tool? Modeling, business planning, POC, technical decision making, question mark. Really, I think, as a process of self-discovery, just drawing out your system. So for example, like if I'm a software developer and I'm drawing out my system, and I identify that unit tests are good for me, right? You might know a lot of these things intuitively, but seeing it in a diagram like this can really help. But what was really the story that I shared at the beginning, the one that was really important to me, was this idea of learning how to draw these diagrams well, and then going to people in different groups, teams that are separated in some way, but connected, right? And then saying, how do we affect each other, right? So, as a facilitator of this exercise, I went from stakeholder to stakeholder, at least the leaders of those groups, and we modeled their system together, right? And then we then took the unrelated pieces of the system, like maybe a tech support team and a software team, and then we drew lines between the two diagrams. And then it's like, oh, an investment over in software can affect the needs over in tech support, or vice versa, right? It could be an investment in the tech services team. Maybe they get a lot more phone calls that have to go to developers that when they run out of people. So if you added a call queue in here and you had dropped calls usually end up going to other parts of the company, right? And so in this case, you could identify that if you increase tech support staff for the volume of incoming calls on a normal day and it's not related to bugs, then the number of dropped calls handled will actually increase the software development team's capacity. And so I personally like this a lot as a communication tool, to interact with, to show connections between teams, and it very quickly builds empathy between people. So does this tool typically inform stakeholders? What value is it driving? So yeah, and again, I think, in this example, you might think, oh, we're having lots of software developers handle phone calls for tech services. If we increase the number of software developers, then what's going to happen? Well, it's actually going to worsen the need, because you'll have some additional capacity for creating features, and you'll have increased number of dropped calls, further hindering the number of things that you can get done. And so it'll be worse to invest in the software team over the tech services team, where if it was an increase in bugs, then investing further in unit testing would be more important, and understanding like where these problems are coming from sometimes are only possible through diagrams like this. Yeah, I see a hand up, Chris.
I just came off mute. Sorry, thank you for the explanation there. One other kind of question here, we'll kick it over to the next person here. We're currently going through, so I work for a pharma company, and probably tell by the prefix of my email, doesn't matter, but or the domain, excuse me. But yeah, on the, we're going through and assessing a lot of different personas that work with patients. And, you kind of have all these different touch points with one person being the patient, right? You've got this person in the beginning, you have this person in the middle, this person at the end. Have you done anything with kind of, would this be a tool that we could leverage to kind of look at those interdependencies? And I'm just kind of, kind of thinking out loud here a little bit. Have you done anything when you're kind of looking at kind of assessing roles and personas within an organization to see, maybe where there's inefficiencies or, some sort of restructuring that's needed? Have you done any modeling like that?
Yeah. So, I think that this is one great tool of many. I think that there's a great TED talk called The Efficiency Paradox, which is really good. It talks about like Kanban and medical. And that's where I would look for, those sorts of systems. I would look for maybe leaning out the process, like involving many touch points. But um, I think causal loop diagramming, certainly in that scenario, you could identify important quantities, and then again, how does one quantity affect another? And you can model the existing process. And humans are really bad at understanding exponential effects. And what happens is these reinforcing loops and these balancing loops, they end up being exponential, right? When our diagram was super simple, it would produce a one-to-one cause and effect. But when you had a reinforcing loop, an unchecked reinforcing loop, then you have these these exponential impacts on capacity. So I would do a combination of like lean systems analysis in that scenario, as well as looking at the complexity theory side of things, and especially causal loop diagramming. I think you can say patients of certain types, and then how that impacts inventory levels, how that impacts staffing, and then even different queues, right? So this is if you look at queuing theory and you look at lean, there's a lot of elements where you could identify where the queue is increasing, right? So like I said, if we added a call queue here, and then we talked about the number of dropped calls coming in this software example, you'll be able to see that quickly, that investing in the in one team over the other, depending on where you invest, is more important, and that becomes really apparent in these diagrams. And then if the system is really big, what you can do is sit down with each of those stakeholders, draw these causal loop diagrams together, and then go from stakeholder to stakeholder, and then do it one-on-one, right, is my recommendation. Because drawing them together might be boring, right? It'll be interesting in the process, but people won't do their best thinking that way. I think instead you do one-on-one a bunch, and then you ask, like, what's the most important quantity? What are the outflows? What are the inflows? Are they positive or negative? Do they have reinforcing loops or balancing loops to them? Once you identify those things and say, thank you very much, and then later get everybody together and say, well, let's all share the diagram and talk through them, and then we're going to connect them together. And now all of a sudden these hidden improvements get created, where you can say investment in this area over here will actually impact this, because we've created this large diagram full of different stakeholders, and they all have side effects on each other.
What's the learning curve on a tool like this? Obviously, you're a SME on this, but what's the learning curve?
Yeah, right. So causal loop diagramming itself, like, you can do this by hand, right? So, but you don't get the simulation. This loopy diagram it's a passion project from Nikki Case, but there are other causal loop diagramming tools out there. This one is just like I don't know, it's fun, and I like it for presentations. But there are certainly like better and more expensive tools that you could be using for this. The really it's those concepts that I think if you just made practice diagrams a few times, like go ahead and create the thermostat example, then like modify, create your own examples, and really I think the hardest part for me was thinking kind of in nouns, or like things that you can count, right? And so a lot of the times, and you even saw me do it during this presentation, a lot of the times I want to go to a verb, like increasing this or decreasing that. And really what it is quantities that are important, and then how those quantities impact other quantities, right? Creating additional inventory reduces your capacity to hold inventory. Eventually you have to, lease other buildings to hold additional inventory, right? That reduces your capacity for manufacturing. So all these things end up with causes and effects, but it's being really disciplined about sticking to quantities. That's super important when you're drawing these out. But learning curve is really not bad. It's really those 5 or 6 main concepts of quantities, increases, decreases, identifying, balancing, and reinforcing loops, and then it's all about interpreting the diagram, right? No model is perfect, but it's useful, right?
Awesome, thank you.
Yeah, absolutely.
Uh,
Yeah,
do-
Chris, yeah. Oh,
Yeah. Sorry I joined late. I had trouble finding the meeting info, but you might have already covered this. On the two nodes, are they called nodes? Each circle? Is that what it's called?
yeah,
Yeah.
yeah. A node, or I refer to them as quantities because it's kind of like
Okay.
the causal loop diagramming piece of it. But yeah.
On the relationship between bugs discovered and unit tests, I noticed 3 lines. So from 3 lines, can I infer that if I multiply the number of unit tests by 3, I should create a 200% decrease in bugs discovered?
No, yeah. So
Is
you
that
want to avoid assigning like real values to this.
okay?
So really, I recommend to people you use this diagram to identify levers to pull in a complex adaptive system, right? And so, if you look at the Cynefin framework and you say we're in a chaotic environment,
Mhm.
and we have this system that exists in this chaotic or complex environment, and we're just trying to create experiments on how to modify the system and then sense and adapt, then here we might say an increased investment in unit testing could relieve this cycle here. And so it may just be, if you're not writing any unit tests at all, let's go ahead and add some and see how that impacts things. If you're already doing unit tests, then you increase the number of unit tests, then you can see like how does that. But if you didn't know that unit tests were a thing, you might not identify this as a way to reduce the bugs, but you might find other ways to impact the system appropriately, and that might include additional staff and stuff. But I would avoid assigning concrete concrete values to these things.
Okay. I guess I was just maybe a little confused because
Yeah.
there's 3 arrows, so that implied mathematical precision to me.
Right. Yeah. No, the 3 arrows just mean that, yeah. I mean, technically we're tripling the strength right here, but a lot of these things in real life, a lot of these quantities in real life are not one-to-one, right?
Gotcha.
When you think about a unit. But the exponential effects are similarly exponential if the relationships you draw are appropriate. And so, if you have a fixed amount of development time and you spend more of that time on unit tests, then, not only will you get out the working feature with a faster feedback loop, but you'll also have fewer bugs discovered. And so in this case, yes, we are tripling the number of unit tests as an experiment to see how the model would react. And then, of course, there's the real life, what are your real life expectations? But you realize that the unit tests here, don't necessarily take away from feature development time in this model. And so at some point, this model will fall apart when you're saying, I'm only writing unit tests and no features, right? But if you're talking about test-driven development, then you are forced to write a feature with each unit test. And that's kind of like the maximum capacity that you can have in that regard. So adding additional lines may not make sense there. Right?
So just so I'm clear, you added additional lines not for mathematical precision, but just to symbolize an increased emphasis on unit testing.
Exactly. Yeah.
It seems to me that part of the conversation around that would be is you're saying, hey, we've got lots of bugs. What should we do? And somebody says, let's add more tech support. And then you have a conversation saying, what really more unit tests will give us a much greater value than just throwing more tech support people out to handle the problems after they occur. And so that conversation, at least the way I'm understanding, would be represented by saying, well, let's draw 3 lines here to help show that this is really valuable and then continue the discussion. Is that kind of the type of interaction that would happen?
Right, exactly. And that kind of models like the red bead experiment where you do quality first, or the shifting left idea, right? So this diagram here actually is a really good case for shifting left because you're adding all of the automation further up in the process. Because with development teams that do have dedicated testing teams, you would have an additional loop back here, but you'd also have additional investment. And those unit tests would, so maybe somebody else discovers that bug instead of the end customer. But that investment also exists. So you could say we need additional testers, right? But that could, in the end, further cripple development time as you add more software over time. And so expanding on the diagram to fit your context is important.
And real quick, I know this, you've emphasized this many times. This model is intended to speak quantitatively. And so I'm assuming there's no way to sort of address qualitative measures. For example, it's entirely possible to have a lot of unit tests that are just crappy unit tests, right?
Right.
This model doesn't address that, obviously, right?
Right. Yeah. I mean, you can say something, you can get more granular, right? So you can make specifically a unit testing, a model just around unit testing, right? And so you could expand this quantity into 10 different quantities, right? So unit tests that, you could have unit tests that run the lines. You could have unit tests that assert the results. You could go through, you're going to create one category for each of the zombies. So a 0 case, a 1 case, a many case. And you can say, do I invest in any of these cases, all of them? One, what's the value? And so you could, the fact is that you can zoom in to any of these quantities and create another model. The whole purpose of the model is to simplify a complex system. And so, I think you want to, appropriately zoom out. So if you're talking to a bunch of executives, their diagram is just going to be much higher level than if you're working across multiple teams in a certain discipline. Yeah.
Okay, cool. Well, that's not good for consultants because we want to make complex systems more complex.
Yeah. Yeah, exactly.
I have a quick question. So between your developers write code and tech support not handled, there's a pretty long connector. Does that affect your delay on that as well? And
Right. Yeah. So in here, if I shorten this, for example, then that will change the way that the model reacts.
okay, yeah. Do you ever have like problems where it's hard to get it to like this right location and the right delay, or so usually you can just move it? It's not a big
Yeah,
deal.
I mean, it really is just moving it around. And again, this tool is certainly less precise than than some of the other like paid tools out there. This one's free, and so people can kind of jump in and model things easily this way. But yeah, as soon as you introduce a delay, then the whole system behaves differently. And things with long delays are really nefarious because, especially if it's like a delay over 5 years, because that's where you get into these conversations with like executives of like, our technical debt is so big and we got to bring in all these consultants to teach us how to do quality software. And the reality is like they're dealing with things that were introduced 5 years ago, right? And so understanding the relative length of that delay often can be very hard, but you can certainly experiment briefly to form a hypothesis, right? So you can use the model to adjust your view of things and create a hypothesis for yourself. And then once you've done that, then you can run the real experiment against reality, and you'll see again very different behaviors depending on how long those delays are, how strong those things are. For example, an integration test runs longer than a unit test, and it breaks more often, reducing development time. So you have different benefits for different investments, and you want to understand the difference between those things.
But I guess to that point, right, Chris, if you think about like the testing pyramid, right?
Right.
If you have increased unit tests, the likelihood of your integration tests breaking goes down.
Right.
Thus, the likelihood of your end-to-end testing breaking goes down. So,
right. So, you might have something like this, but you might have that be reduced, but there's only a 1-to-1 there.
Mhm.
And so you can kind of see that. Right.
Do you have any examples that you can share of kind of that transition from saying, hey, we worked out this model, we have some ideas, now let's try and experiment in the real world and see if it, see if our model works for that, or if we pull this lever, we think we'll get this result. Do you have any stories around kind of doing that?
Yeah, I mean that very much was that call queue example was real, and in the sense that we were talking about, do we increase staffing in a particular software development team, or do we increase staffing in a tech services team that handles calls? And often those calls, dropped calls in the queue, end up going to like, oh, I couldn't get anybody on tech support, so I'm going to call somebody else at the company that I know of. And so what ended up happening is those things would get inappropriately allocated to the software team, even though they could have been handled by somebody in tech services. And so the realization between those two leaders was that adding more software developers won't help the problem. It's really adding tech services people so that the call queue does not grow large enough, right? Because eventually you have so many customers that your average call volume is going to grow. And even if you have no bugs, no known bugs in production, for example, and you just have people trying to understand the software for the first time, then those calls will come in at an increased rate based on the usage of the software. And so at some point, I think every software team will face this, where it's like their customer base has grown to a point where it's putting strain on developers, where it was just like an early escalation, right? It was something that shouldn't have happened in the first place. And so queue length, is a really important quantity when you're handling calls based on a product. And it's hard to identify where to invest. And so the problem would have just become worse, and the investment would have had to increase even more by adding new developers, because the call queue would have become longer as the popularity of the software increased over time. And so it's often very difficult to identify those things. So once we did those, those two diagrams were done completely separately. And then we drew lines in between the diagrams. And we were like, here is this giant reinforcing loop that takes like 6 months to happen. But because of the release frequency of that team, it was in larger batches and other things along those lines. And so you could see that there was like this like spike in need and a bunch of dropped calls. Those calls end up trickling down through the system and then reducing the capacity of the software team. And so the way to increase the growth of the software, and therefore the profit of the product, was not to invest in software developers, but to invest in support people that could work with people newer to the system.
Ian was asking if there's a way to create a one-to-one message in the model, not an increase or decrease.
A one-to-one.
Yeah. So I'm just thinking, well, I started playing with like reducing batch size, increase frequency, reduces batch size, and so on. And then I would start thinking, how would I expand that and be like, okay, I would want to raise an RFC. So for each release, I would have one RFC, but that would probably lead on to other bits like more RFCs is going to be more stress on the development team and so on. But that
Right.
RFC process is still one-to-one with the release kind of frequency. So I was just wondering, is there anything like that in there?
Right. So again, you need to think about it in the idea of quantities. So like in my slides here, I had this one where and you could add things like pull requests or other things, right? And then so it's either you simplify it in your model to say an RFC reduces development capacity, or you just use that. Like, so if it's a one-to-one, like you say, you're going to create a single unit of code, right? So or like code for a feature, right? And if you have code for a feature and you need an RFC, and then then that just goes one-to-one, right? So you create code for a feature, it becomes an RFC, and so on. It just keeps it, as you add one, it will increase one. But then it's, you know, if you have, these might be outstanding RFCs, right, versus processed RFCs. So what does the RFC lead into next, right? So what quantity does the RFC modify, right? So code for a feature might not be released into production. So once the RFC is processed, then it might lead to a released feature. And so, you know, again, you don't want to name the verbs. You want to just stick to nouns, and that will help you when you're drawing the diagram. So, you know, does that help, or that make sense?
Yeah, I think I need to do a bit more thinking than the 30 seconds here, getting excited of all the great things I can do.
So, you know, the book, The Fifth Discipline by Peter Senji, is really good, and the beer game was a really interesting. They basically had this exercise that they talk about in the book called the beer game, and it talks about, you know, a manufacturer of beer, a distributor, and, like, you know, the end liquor store and the end consumer, and so it's like a four-tier consumption model, and they talked about, you know, how those different systems interacted with the quantities. And they very briefly talk about this concept, but my thinking around complex systems, a lot of it is based on the concepts introduced in the fifth discipline. And these models, even though they spend very little time on it in the book, the reasons why you would want to do it this way are outlined very well in the book. So I highly recommend that.
Yeah, I had the Kindle edition of it, but the diagrams in that were really hard to read. So I have a paperback version now that I haven't got around to yet.
Cool.
But yeah, I remember reading about the beer game only a couple of weeks ago, when they were saying that in that there's a shock in the first couple of weeks of the game where you suddenly get a rush order, and then people are trying to compensate the whole way through, and it just, you know, there's just wild swings based on people trying to compensate for what happened a long time ago and is now stable.
Yep.
A great update to it would be like the toilet paper shortage, because that's kind of a similar tier distribution. Yes. When the Hey, we're coming up on the top of the hour. Any last questions anyone wants to ask? Okay.
All right. Well, you can reach out. You can find me on, I have a blog at chrislucian.com. We talk a lot about similar things on the Mob Mentality Show, and I co-host with Austin Chadwick, and you also can reach me on LinkedIn, and things, you know, like that. So, yeah, thanks everybody.
Hey, Chris, thank you so much for coming. And everyone, check out his blog. I was looking at it a few days ago. There's lots of great stuff there. And the Mob Mentality podcast is also a great resource. So I encourage you to check those things out. So everybody have a great rest of your week. We're going to be looking at the seventh Agile Principle next Tuesday. We've got a new cartoon. Some of you may have seen it, but we're going to be releasing that and talking about the seventh Agile Principle. So hope to see you there. Have a great rest of your week. Thanks, Chris.